So we are thinking about the density of an atom, and we're thinking about the mass of an atom. And how can we even know what the mass of an atom is when it's so tiny? How can we measure it? How can we measure its volume? So we have a couple paragraphs here. I'm trusting that you've read them already. So I'll go ahead and read them, and then we'll mark them, and when we'll talk about this a little bit. So one type of matter found on Earth is called an element. All right. So an element is a form of matter made up of one type of atom. Gold, for example, is an element made up of only gold atoms. Now, that would be true as long as we're talking about pure gold. An aluminum can, if it's pure aluminum, is made up of the element aluminum. That means that an aluminum can is made up of only aluminum atoms. So let's just say, for example, let's just say that I have a gold bar, okay? And let's just say that this gold bar is pure, okay? We're talking pure gold, right? Every atom in that gold bar will be exactly the same. All atoms the same. Now that's important to think about because different atoms have different masses, and we'll see this. Okay, so let's go ahead and finish reading. All of the atoms in an element are basically alike. Sometimes, however, the number of neutrons in the nucleus may be different, actually, from the number of protons. When this happens, you end up with what's called an isotope. Now, an isotope's an atom, but it's not a pure atom. So most elements have several isotopes. The element gold has approximately 50 isotopes. Each isotope has a different number of neutrons in its nucleus, but it is still considered to be the element gold, and that's because of how many protons are in it. So let's make some sense here, and let's get some things written down. Get your green marking pencil. You've got a couple of, so an element, and let's just write here pure. A pure element is an element made up of one type of atom. So this is a substance that's made up of one type of atom. We could just put here substance. Because if we're not talking about gold and we're talking about some other element, then but a pure element is made up of one type of atom. Okay, so however, isotopes are atoms where the number of neutrons in the nucleus actually maybe are different, and that's different from the number of protons. Okay, so when this happens, you end up with what's called an isotope. So an isotope is an atom that has a different number of neutrons than it has protons. An atom of a pure element is going to have the same number of protons as it has neutrons. Okay? And in a pure element, all of the atoms are going to be identical. They're going to be exactly the same. So I have here just a little sketch of the periodic table. actually the first three periods of the periodic table, the first three rows or periods. And you as sixth graders will be responsible for having a pretty good understanding of the elements that are listed in the first three periods of the periodic table. So there's 18 elements, you know, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. These 18 elements, you need to have a pretty, you'll need to come to have a pretty good understanding of what the atoms look like for these elements. So, I want to show you. I have a little chart that I'm going to put up in a different video, in the next video, and I'm going to chat about it just a little bit. So I want you to get your reading marked the way we've marked this right here, and make sure you have at least a beginning understanding of the difference between pure atoms, or atoms that make up a pure element, like that's, you know, all gold or all aluminum or all carbon, and what's the difference between a pure atom and an isotope. Well, let's look at this chart, and we'll see if we can make a little more sense of what's going on with pure atoms and isotopes.